Hello guys, so in this video we will discuss about applications of similar triangles. So just like congruent triangles, similar triangles also have some real life applications, and before we go into that we can just see some examples and some basic understanding about similar triangles. So here's an example which says that identify the similar triangles and prove that the triangles are, they are similar. So identifying is easier. It's just that proving part, we again have to use the properties or the test, similarity tests like side, 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 and angle, angle. So usually it can be this on the third one is as angle, angle, angle. But if two angles are equal between two triangles, definitely the third one will also be equal. So that's why most of the time we don't have to write the third angle. It's just two is already enough. So how do we show that? How do we prove that the two triangles are similar? In this case, identifying part will be triangle ADE and triangle ABC. Now, in these two triangles, angle D will be equal to angle B and angle E will be equal to angle C. The reason they are corresponding angles, also known as F angles, because you see there are parallel lines in this part. Okay, so these two are the parallel lines and hence they will form the corresponding angles at this place, and this place, and this place. You can always say that this is the same angle. So if you want, you may write that as angle A equals to angle A, and that's a common angle. All right, so this is corresponding angles, and therefore you can say triangle ADE is similar to triangle ABC. So that's a notation for being similar. Now, what can you say about the corresponding sides? So once, in this case, we already have three angles here. So about the corresponding sides, whenever two triangles are similar, which means they are having same shape but different size. So if a different size, the relation between the corresponding side is you take the ratio of those sides as AD over AB, and that will be equal to the ratio of the other corresponding sides as DE and BC, and then the third pair will be AC and AE and AC. So you can see that that's AD, AB, then DE and BC, and then AE and AC. So if you have the statement, from just the statement without knowing the diagram, you can still write this, the ratio part, the ratio of the side, that will be always equal. So that's it in this part, and now let's have a look at the next one. So in the next question, again, it's similar to that. You have to identify and you have to prove. So in this case, it's again parallel sides. Now proving part, you can just take this as the corresponding angles Q and P because they are parallel lines, and S and T. And if you want to have another angle, you can just write R equals to R. So the order will be either you can go with RSQ or RQS. Just follow the same order for writing whichever you start with. So I have started with RSQ, so I will go with RTP, and that's using the angle test or property, so AA test. And then take the ratios for what can you say about the corresponding side. So that's RS over RT equals to RQ over RP. Following this, RS, RT, SQ. Okay, so this is supposed to be SQ over, so what I did is I have written RS over RT, then RQ over RP equals to SQ over TP, SQ over TP here. And since we know that that's actually 4 and 7, so all these ratios gonna be equal to 4 over 7. Okay, so that's the next part, part B. Now here, there are two different triangles, different shape you can see, but they might be similar, but we still have to prove it why they are similar with proper reason. So one of these identities should be working there. In this case, when you look at triangle ABC and JKL, there is angle A and angle J, which is 55 degrees. That's already given. If you look at the ratio for each corresponding side, for example, AC over JL, which is 3.5 over 7, which is of course 1 over 2. You can see that that's half of 7. And then AB over KG or JK, which becomes 5 over 10. But remember, when you write the similar, therefore in this case ABC is similar to JKL, that order is important. A with J, B with K, and C with L. And in this case, it's angle side test, which means the side and then the two sides, and between them there is this angle. So you can see the two sides, and between them this angle is there. So that's why it's side angle side test. And what can we say about the other sides and other two angles? So other two angles, B will be equals to, from the statement, B equals to K, that's here, and C, angle C equals to angle L, that's in this part here. And about the other sides, which is BC and KL, even though their dimensions are not given, but we know from here these two are half, so this ratio is also going to be equal to half always. Okay, the next example is, let's say in this case it's given already that the triangle EDA and CFA are similar, the two triangles. So triangle EDA is similar to triangle CFA. In that case, you don't have to prove that they are similar. It's already given. No need to worry about that part then. So if they are already given, they are similar, we can have this ratio ED, this ED over CF equals to DA over FA. Get the statement, this ratio part from this statement, and then just look at the diagram. What dimensions do we know? So ED is 5, put it there. CF is W, so we write that here, and DA 15, FA 60, which is given here and here, and then just cross multiply, just normal math. Reduce it, 15 times 4 is 60, 4 times 5 is 20, and you have your answer. So the distance between, or basically the width of the river, can be found even without knowing or crossing this part here. Just get the similar triangles and you can easily get this distance on this part. Okay, so now the next example. In this case, there is the mobile phone tower and the man, and let's say we get the sunlight this way, so that's falling this way here. Draw the triangle here. In this case, it's not directly given, but if it's given, we can directly write the statement. But it's not difficult to find. This angle A is a common angle between this small triangle and the bigger triangle. And another is this 90 degrees, 90 degrees. So angle by angle property, you can have these two triangles similar, or you can also consider this one, angle E equals to angle C. That's the corresponding angle because these two lines are parallel. So get the ratio again, AB over AD equals to BC over DE. Substitute the known values. AB is 6 from here, so you can see that here, and AD is 60. So 6 over 60 equals to BC 1.8 over the height part. Cross multiply, simplify, you get the height as 18 meter. And then we have the last question for today in this worksheet. So here some informations are given, and they didn't say that XAB is parallel to XYZ. They just I mean XAB is similar to XYZ, but they just say the two lines are parallel. So again we can prove that the two triangles are similar triangles because of this reason here by angle test. Once you get that they are similar, you can have this statement: the corresponding sides will be always equal. Substitute the known values. XA is 1, so 1. XY is 1 plus A in this part, so 1 over 1 plus A. AB over YZ, that's easy, it's 3 over 9. And then we have XB over B plus XC as B over B plus 5. That's XC, not just 5 here. All right, then you can make two separate equations. So this part here is 3 over 9. You can just simplify that as 1 over 3, and that's why you can see that it's written as 1 over 1 plus A equals to 1 over 3. Cross multiply, solve this everything. A is equal to 2 and B equals to 2.5. And then just substitute back in this part here. and you will get the value of xa over ay as 1 over 3 and xb over bz as also 1 over 3. Now they ask you, is xa over ay equals to xb over bz? We can already have that. The moment you prove that these two statements are true, you can already see that in this part you already have them equal, so you can directly get it here. You don't even have to calculate anything. But again, since they ask you to find this, you still get the same value. So yes, they are equal. So you may write it here, or you can make a different statement at the bottom. All right, the next one, as the application of similar triangles, it's, as I mentioned, it's also um, used in radiation therapy. And you can watch the video. It's a nice video. You can watch it on this link. And there is a similar diagram you will find on your textbook on page number 325, which is a solved example. Have a look at that, and that's it. Once you are done with that, you can solve some more questions from this exercise, and that's it. Thank you, guys.